Good morning. Our topic is linked list. Linked list is used to store a collection of data. These data will be stored in a sequence of node. This is how a node will look like. Node has two parts. One is the data part and another is the link part. The element that we are inserting will be stored in the data part. Let us see this with an example. Now we are going to insert the element 5. This is a node. In the data part of the node, the element 5 will be inserted. The link part, here the address of the next node will be stored. There is no other nodes left, so null will be stored here. Then now we have to store this node in the memory. A node takes 4 bytes in a memory. This is because the element that we are inserting is an integer. It takes 2 bytes. And this pointer, it takes 2 bytes, totally 4 bytes. This node will be inserted here 110 in the memory location 110. This 110 is just an assumption. It is for our convenience because the address of memory usually will be in the form of hexadecimal. But for our convenience, we are taking it as 110. The address of this node is 110. Now, let us insert a sequence of elements. For example, 2, 3, 10, 20. For inserting these 4 elements, we have to create 4 nodes. These 4 nodes has to be linearly linked. Now we are going to insert these 4 elements. It should be inserted in the data part of the node. So 2 will be inserted here, 3, 10, 20. Once the node is created, it has to be stored in the memory. Let us assume that this node is stored in the memory location of 100. 4 blocks it is used to store in 4 blocks. Each block represents 1 byte. So totally 4 bytes. The next node, this will be stored in 104. What is the gap between 100 and 104? It is because this node is stored in 4 bytes. So this is 100, this is 101, 102, 103. So this node will be stored from 104 till 107. Then where will this node will be stored? Let us see the next byte. But only 2 bytes is available because we have already stored the element 5 in the location of 110. So we are going to store this here. 114. Then where will this node will be stored after this? 118. So let us write down the address. This node is stored in the address of 100. This is 104. This is 114, 118. This node is the link part, which is used to store the address of the next node. For this node, this is the next node, so this address will be written here. For this node, this is the next node, so this address will be written here. For this node, 20 is the next node, so 118. For this node, there is no other nodes left, so null will be stored here. There will be multiple linked lists. It is not possible for us to remember all the address of the first node because to access a linked list, we must know the address of the first node. So for this problem, we will store the address in a pointer. This pointer is called the header. Now we are going to see 2 operations in a linked list. One is the insertion and another will be the deletion. First, insertion operation. Let us consider we are going to insert an element 7 at the location 150. So 150 is between 100 and 200. So a node will be created here and 7 will be inserted in the data part of the node. 150 is this location. Now what will happen? This node has to be inserted here. So a link is created between these 2 nodes and this link has to be deleted. This once the node is created, it has to be stored in a memory. For storing the node in a memory, a special function will be used, which is malloc. Once it is stored in the memory, this address 150 will be written here, and this address 200 of this node will be written here. This is how a node is inserted. Now we look into deletion operation. Let us consider that we are going to delete the element 35. We are going to delete the element 35. It is a one pointer change operation. Deletion is just one pointer change. That is, once this element is deleted, that is this node, this is going to be linked here. What is that one pointer change means? This 400 will be replaced here. Just a single pointer change. In deletion operation, a special function will be used, which is find previous. This function is used to find the address of the predecessor node. Once this is deleted, this will be attached here. This is how a deletion operation will be done. There is a special case in both deletion and insertion. It is, if we want to insert an element before the first node, or if we want to delete the element 5, which is the first element in this linked list, it should be done very carefully, because any mistake done here will result in losing the entire linked list. To avoid this situation, we have to use the header to store the address of the first node. Representation of a node structure. We all know how a node will look like. The data part contains the element and link part contains the address. The element is of the type integer, whereas the address is of the type pointer. Both are variables, but not of the same type. So a user-defined type structure is used here. Node. The data is of the type integer. The next will be pointer. Let us consider it as a next, because it is going to point the address of the next node. This is how a node structure will be represented. Now, some of the common errors in linked list are the fake address, malloc function, and the free command. First, we look into the fake address. Let us consider a situation in which we are going to search the element 25. Usually, traversal starts from the first node, so this node will be referred first. Then, by using this address, the next node will be referred. But when we are referring this address 200, if the system throws an error of memory access violation or segmentation violation, this means this node is not properly initialized. The next function is malloc function. In this case, we should be clear when we should use the malloc function and when we should not use the malloc function. Malloc function can be used to allocate space for a node in memory, but it should not use it to run down a linked list. And the third error is a free command. let us consider a situation in which we are going to use this free command in order to remove the element 25. The element 25 will be removed, but the address 100 will remain unchanged. Now, what will happen to this address? It will remain idle. We cannot store any other element in this address. This will result in wastage of the memory. Some of the advantages of linked list are these three, and we will be looking into one by one. First one is dynamic memory allocation. In an array, the size of the array has to be predefined, but it is not like that in a linked list. We can store how much ever element we want until the memory becomes full. The second is not necessary to store the node continuously. Let us see this with an example. In an array, if we are going to store these 4 elements, then it should be stored continuously. For example, 5, 6, 7, 8. But if these elements are stored in a linked list, 5, 6, 7, 8. The list can be broken and the nodes can be stored separately. This is one of the advantages of linked list over array. Then third is insertion and deletion is easy. Let us see this with an example. There are totally 3 nodes with the element 5, 6, 7. These are the addresses, the 300 and 9. Now we want to delete the element 6. Let us see what will happen in array and also what will happen in linked list. Only by comparing we can get a better understanding. Let us assume this is an array memory 5, 6, 7, and this is for linked list. We are going to delete element 6. In an array, if we delete element 6, then this element 7 has to be moved one cell before. But if we delete an element 6 in linked list, it is not necessary to move this element 7 one cell before. These are the advantages of linked list. These are some of the disadvantages of linked list. We will discuss the first 2 points by comparing with array in order to get better understanding. The first one is occupying more memory. If we want to store the element 88 in an array, it will take just 2 bytes because it is an integer. If we store the same 88 in a linked list, it will take 4 bytes because the integer will take 2 bytes plus the pointer, that is the link part, it will take 2 bytes, totally 4 bytes. Next is accessing an element is difficult. First, let us see in the case of array. The 3 elements are stored in array 88, 23 and 7. The index value for 88 is 0, 23 is 1 and 7 is 2. If we want to access the element 7, just by indicating the index 2, we can directly access 7 without accessing 88 or 23. But whereas in linked list, if we want to access the element 7, the first node of the list has to be accessed, 88. Then by referring to this address, the second node with the value of 23 will be accessed. Then by using this address 300, the node having the value of 7 will be accessed. This is the difference. And the third is binary search is not possible because in a linked list it is not necessary to store all the elements in a sorted manner.